Hello, Algebra 1 students. This is Lesson 19. Our objective for today is how do you solve equations using addition and subtraction. So let's just think about it for a second. You have a scale, and you have the same number of objects on the left and the right. We would say that these two amounts are equal. Notice I have a yellow triangle, a red square, a green circle. If I wanted to, I could add something to both sides. Let's say a blue square. And those would still be equal as long as I added the same thing to both sides. If I added two different things, they wouldn't be equal. But if I had the same thing, then we'd say they're equal. Likewise, I could also kind of take one off. If I wanted to be like, okay, let's remove that yellow triangle from both sides. Those would still be equal. Even though they weren't the same as what they started with, they'd still be equivalent. Both sides would still be equal, and that's what we're going for. So, whenever you're trying to solve equations, remember that that equal sign means equal. So if you have two things that are equal, and you add or take away the same from both of them, they're still equal. Like if me and someone had the same amount of money, and you took $5 from both of us, we'd still have the same amount of money. Inverse operations are operations that do the opposite of each other, where they're like enemies of each other. They do the opposite. So addition and subtraction do the opposite of each other. Multiplication and division do the opposite of each other. And we'll talk about more multiplication and division later, but right now we're just going to do with addition and subtraction. So our goal, as we're trying to solve these, is just trying to get the unknown piece, the thing we don't know, most time was represented by a letter, by itself. Let's try that out. N plus 17 is equal to 20. N plus 17 is equal to 20. So you might be able to just look at that and say, oh, the answer is obviously 3, because 3 plus 17 is equal to 20. But it's not the point. We're trying to understand a concept here. So what we're trying to think about is we have a number, we're adding another number to it, and we're getting 20. So it'd be really easy to know what that number was if it just said n is equal to 3, right? That'd be really easy. So let's see if we can get that. To do that, what we're going to do is we're going to add the opposite of this piece. That piece is a positive 17, so I'm going to say n plus 17, that's what's already there. And then over here is 20. So notice I've just rewritten that equation. What I'm going to add to both sides, or really what I'm going to take away, is 17. Why I'm doing that is because this part right here, notice I have 17 minus 17. 17 minus 17 is 0. So my next line would look like this. N plus 0 is equal to, well, what's 20 minus 17? 3. And n plus 0, everybody knows what n plus 0 is. That's just n. So n is equal to 3. And that would be my answer. If you wanted to check it, you could take that and plug it in right there. Is 3 plus 17, is that equal to 20? Oh yeah, 3 plus 17 is equal to 20, so it does work out. So you can't actually check your work on this. Okay, let's try another one. 10 is equal to y minus 3. So what I'm going to do is I'm going to rewrite that equation. 10 is equal to y minus 3. And again, I'm trying to get that y by itself. So then I'm going to do the opposite of what's there. Right now, it says y minus 3. So the opposite of minus 3 is going to be plus 3. So I'm going to add 3. And if I do it to one side, I must do it to the other to keep this side equal to that side. So notice this side is equal to that side because I've added 3 to both of them. Well, the left-hand side is fairly easy. 10 plus 3 is 13. And then this part right here, negative 3 plus 3 is just 0. So on my right-hand side, I have y plus 0. Well, y plus 0 is just y, So I have 13 is equal to y, or normally we write the variable first and we say y is equal to 13. This is right too. Okay, a couple more. Let's see here. Rewriting this, negative 5 is equal to x minus 7. So notice here I have a minus 7, so I'm going to do the opposite of that. I'm going to add 7. So if I add 7 to the right, I'm going to add 7 to the left. So then negative 5 plus 7, since those have different signs, one's negative, one's positive, I'm going to subtract them. So 7 minus 5 is 2. And I keep the sign of the bigger one, which is 7, so it's going to be a positive 2, is equal to, well, this part right here, negative 7 plus 7, again, different signs, so I subtract them. 7 minus 7 is 0. So I'm going to have x. You could say minus 0 or plus 0. I'll just stick with plus 0. X plus 0 is just x, so I'm going to have x is equal to 2. Now, notice, if you've noticed these several times, we have this y plus 0, and then see how this line looks very similar to this line? We start to realize that negative 3 plus 3 is 0, and y plus 0 is just y. So after you do these several times, you'll be able to start kind of skipping this step right here, or this step right here, where you say n plus 0. And you'll be able to skip from here down to here, because you realize, well, negative 7 plus 7 is 0, and x plus 0 is just x. So that's what I'm doing. This next one is I'm going to kind of skip a line, but just realize that what I'm doing is I'm skipping that x plus 0. So this looks like this is 6 plus x, and is equal to negative 1. Well, notice that this 6 is a positive 6, right? And then it's adding x. So what's the opposite of adding it? Adding 6 would be subtracting 6. So I'm going to subtract 6 from both sides. 6 minus 6 is 0. 0 plus x is just simply x. And then negative 1 minus 6, and so it's have the same sign. We add the numbers. 1 plus 6 is 7, and keep the same sign. So this is going to be negative 7. So x is equal to negative 7. I forgot to box this one in. Okay, another one here. X plus 1/2 is equal to 3/4. So still same principle here. I have x plus something, so I want to subtract that something. So I'm going to say x plus 1/2 minus the 1/2 is equal to 3/4 minus 1/2. Now we remember that we can only add or subtract if we have the same denominator, so let's just kind of go up to the thought bubble here. 1/2 is the same thing as 2/4. I got that by multiplying this by 2 over 2. So then what we would have is 3/4 minus 2/4, right? Because the 1/2 from over here is the same thing as 2/4. So instead of the 1/2, I'm writing 2/4. And then we just subtract the numerators. 3 minus 2 is 1. The denominator is 4. So then this part right here becomes 0. 1/2 minus 1/2 is 0. So I have x is equal to 1/4. Okay. Now this is actually a couple of your practice sets, practice set A and B. But it's kind of just asking you, it says state whether the value of the variable is a solution. Meaning, this piece right here, is it actually an answer for this part over here. The easiest way to find that is to plug this 12 in. H is equal to 12, so let's just plug that in for H, and we have to come out to see if this is true. So what we're going to do is we're going to say H is the same thing as 12, so I'm going to say 12 minus 14. Is that equal to 2? So I'm going to just put the question mark there to see if it's true or not. So let's see here, 12 minus 14, they have different signs, so then I'm going to subtract. What's 14 minus 12? Well, that's 2, but I keep the sign of the bigger one. So this is the bigger one, right? If I had $12 and spent 14, I'd owe $2 still. So this is going to be negative 2. Is negative 2 the same thing as 2? Well, if you say yes, then let me borrow $2 from you, and it'll be the same thing as you having $2. So are these two the same? No, they are not. So then I would say not a solution. Because remember up here it says state whether the value of the variable is a solution. So I'm going to say it's not a solution. If it came out to be true, then I would say is a solution. So let's try this one over here. Negative 11 is equal to j minus 4. I happen to know that j is the same thing as negative 7. So I'm going to see negative 11. Is that equal to negative 7 minus 4? So I'm going to look right here. Negative 7 minus 4. So these are the same signs. I'm going to add them. 7 plus 4 is 11. I keep the same sign, so it's going to be negative 11. Is negative 11 equal to negative 11? Well, yes, it is. So I'm going to say is a solution. Your homework is starts on page 107. You're doing all of them from lesson 18, all from lesson 17, and 7 more of your choice. Good luck.